This video will explain the gauges display. Additional videos are available for all facets of the FIC and will explain each setting and function in detail. There are two ways to access the gauges display. First, you can click on the View menu and select Gauges, or you can simply click on the Gauges icon. Once opened, you're going to see three gauges across the top: RPM, Load, and AFR. These gauges are fully customizable. The way that you customize a gauge is by double left clicking on the gauge itself. Let's start with RPM. First thing that comes up is the overrev alarm. The way you adjust this is you click on the gauge needle and drag it while holding down the left mouse button. We'll click here and let's move it to, say, 8,500 RPM and then release the mouse button. There. Double clicking again will advance you to the next configuration item, which is the start location of the yellow band. Let's make it 6,500 RPM. Again, left clicking on the dial and dragging until we get 6,500 and releasing. Double clicking again brings up the red band, and let's make that start at 7,500. Again, clicking on the dial and dragging it to 7,500, releasing. Double clicking once again cycles to the next mode, which is the full scale value for the gauge. And let's set it to 9,000 RPM. Again, double clicking and dragging until we get to the 9 display and then releasing. Now, double clicking one last time exits you from the configuration mode and the new gauge settings are displayed. You see it now has a 0 to 9,000 RPM range. The yellow caution band begins at 6,500 RPM. The red warning band begins at 7,500 RPM. And the overrev alarm will activate at 8,500 RPM. Okay, let's see how it looks. So you see that at 8,500 the dial itself starts to flash, indicating the overrev. Now the exact same method is used to set the load gauge. But before doing that, let me take a minute to explain the load units. It is very important to understand that this is a load gauge and not a boost gauge. What's the difference? Well, actually quite a lot. The boost gauge measures pressure above atmospheric. So 5 psi of boost is really saying you have 5 psi more in the intake manifold than outside the vehicle. So boost does not give you an actual pressure in the intake manifold. It only gives you a relative value when compared to the local ambient pressure. Load, on the other hand, is a measurement of the absolute pressure in the intake manifold, since load is what is used to determine how much fuel to add to an engine. The amount of fuel depends on the density of the air, and that relies on the absolute pressure. For example, if you have two identical cars running 10 pounds of boost, one at sea level but the other at 5,000 feet, the one at the higher altitude will make less power and will also consume less fuel. And that's because the pressure in the intake manifold for the high altitude vehicle will be less than the one at sea level, despite the fact that they're both running 10 pounds of boost. Since our concern is for fueling the engine, we must use manifold absolute pressure for load, and you need to keep this in mind when you use the load gauge. When the engine is turned off, the load gauge will not read 0. It will read your local ambient pressure. Here, at sea level, it's 14.7 psi. So 10 pounds of boost at sea level will give an absolute pressure in the intake manifold of 24.7 psi. This is of critical importance to understand, as all load values in the FIC, as well as all electronic fuel devices, use absolute pressure measurements. Now, configuring the display of the load gauge is exactly the same as showed for the RPM gauge, so we won't do that again. But let's go to the third gauge, which is AFR. Actually, it's not just an AFR gauge. This is a universal gauge. We pre-configure it as an AFR gauge because that's most likely how you would use it, but you could configure it to display any 0 to 5 volt device you attach to the FIC. Now this gauge is configured differently than the others due to its universal nature. To configure it, you double left click the gauge and a new window pops up. On the left side, the first value is face name, and that is the text that's displayed on the gauge face. Next is the units, which is the text displayed above the numeric readout on the gauge. The digit DP is the number of digits after the decimal place displayed on the numeric display at the bottom of the gauge. The scale DP is the number of digits after the decimal place displayed on the numbers around the circumference of the gauge. Scale max and scale min represent the largest and smallest values the gauge can display. Scale major ticks is the number of major tick marks with numeric values displayed on the face, and scale minor ticks is the number of smaller ones displayed. The yellow start is the value above which the yellow caution band will be displayed on the gauge face. The red start is where it will begin displaying the red band, and the alarm is where the indicator will start flashing. These three are just like the other two gauges. The table on the right allows you to enter a voltage input and the corresponding display value. The FIC will linear interpolate between these values. The numbers you see on the bottom are displaying the real-time values for all the functions in the FIC. The first one is TPS, and it represents the current throttle position sensor value in percent. MAF in is the voltage being received on the MAF in wire, and MAF out value is the voltage being sent to the ECU on the MAF out wire. O2 bank 1 and O2 bank 2 are the current voltages being read on the two O2 sensor tap wires. Switch 12 volts DC is the current status of the FIC's switched 12 volt output driver. Battery displays the current system battery voltage. Normally it will be above 12 volts except when you're powering it off the USB cable alone in bench mode. The fuel trim value shows the current trim amount in percent that the FIC is modifying the factory fuel pulse width, and a shorter pulse will be shown as a negative number. The ignition trim value will either be a negative number representing retarded timing from the factory value, or 0, which represents no change from the factory timing. The analog A in and out show the current values for the user-defined channel A and B voltage remappers. The injector duty values show the injector duty output percent, which you should always keep an eye on when increasing the fuel pulse duration. If you start to regularly exceed 90%, then it's probably time for bigger injectors. That's basically it for the display page. Please select additional videos for detailed instructions on specific functions.